To start tracking, you first go to the New View on the File menu, or the New View icon, and pick an image file. The only files that will show here are the ones that can be read by Tima. Tima will ask you to confirm the file name and also the frame rate at which the imaging was done. For an AVI and others where the frame rate is not in the header, you will have to adjust this. This is a listing of the types of files available. Check the most current listing with your Tima agent. Now pick a point and add it to the head, and then right-click on that point and set the point up. First we will give it a name. Next we will ask it to accept lost points while tracking, because there is a flash in this image which we want it to coast through without being distracted. It will ignore losing the point for up to 3 frames now. For such tracking as this project, Tima Automotive offers you either the quadrant tracker or the correlation tracker. The tracking accuracy is respectively about 1/10 of a pixel and 1 pixel, so if there's a way to use the quadrant or bow tie tracking targets, you should do so. Whereas the correlation tracker finds the image within the purple tracking circle, it does not lock on. You can still move it manually. The quadrant target, however, locks onto what it thinks is the center of the quadrant. If you need to move it, you need to press the Alt key to overwrite this lock. You also need the Alt override if either the correlation or the quadrant target gets locked on the very edge of the image and you need to move it. We will set the purple target area within the outer diameter of the quadrant target placed on the head. Then we will also set the search area. The bigger yellow box is the search area for the first and second frame. If frame-to-frame prediction is used, we can set the smaller box for use in subsequent frames, making sure we check the reduce after second frame box. Frame-to-frame prediction tells the tracker where to expect the target in the next frame, based on the motion in the previous frames. Only use this for fairly predictable motion. Making the search area smaller not only saves time, it prevents the tracker from seeing the other parts of the image where there may be other similar targets it could jump to. Now save your setup. Add 2 points we can use for scaling. With the depth control in Tima Automotive, these points can be in another plane. We will call them scaling points 1 and 2. We do not need to be careful with the setting, because we will only track manually in the 1 frame for the scaling. Now we can set up the scaling system in multiple parallel planes. In other words, the motion can be in more than 1 plane, but the scaling points must both be in one of the planes. With static scaling, using only 1 frame, we set the time at which we track the scaling points by clicking the clock. We need to define the 2 points which we know the distance between, in this case 24 inches, and we need to define the distance between the reference plane, where the scaling points are, and the camera. Then we must define the distance of all other targets from the reference plane, nearer the camera being a negative distance. Now we can save our scaling. The blue navigation buttons are video controls, no tracking is done. The 4 buttons with the targets on are the tracking buttons, 2 forward and 2 backward. The inner ones track only 1 frame and only need to be used if automatic tracking is poor due to poor images. This image sequence goes beyond the point where we can track, so go to the last frame you want to track, then go to the Edit Time Properties option and click on the clock to set the end time for the sequence. This will not edit the image, only restrict the visible portion. We could have scaled dynamically in each image if the motion had not been in one plane, but that would have involved tracking the scaling point in each image. As we do not plan to do that, we will turn the scaling points off and only track the head. Now we will add a diagram in which we will put the head target onto our list of track points, and we will plot the position. We could have selected velocity or acceleration, and we will plot the motion in the x direction, the horizontal direction. Now we will set up a point table or spreadsheet, and again we will put the head target on and use the position. We will plot x and y in absolute values, that is, select all values. Now we need to move the dialog box and say OK to save, and we can press the track button, tracking one image to begin with and then tracking the complete system. As we track, the graph and spreadsheet will be generated, and now we have completed our first simple scaled track. While tracking, you should be careful with the setting of each point. On means the point is tracking, off means there is no tracking, and no data will be recorded in the off position. Previously tracked data will not be overwritten. The Z or sleep mode records a sleep position and will overwrite previously tracked data. If the tracking is lost, as noted on the bottom left of the screen, you can manually place the point. But note that after manually placing it, later automatic tracking will not overwrite this manual placement. Note also that M will appear in the point list for that position.